This question is saying if a PMOS FET with WL equal to 56.4, I'm not going to read out the rest of the values, but we have these values here. And we're asked, what is the magnitude of the drain current in microamps? We're going to also use this VTP and K naught P, and we have a lambda here. So this is important as well. So for this, we are going to have to use one of these equations, and that's in the notes linked below the like button on page 85. And so with these, we can solve our problem. However, we do have one problem that we need to get to before we actually write for this. So notice it doesn't tell us if it's in saturation or if it's in triode, and that's important. The way we can figure this out though is pretty simple. We have three things that we have to compare. So we have a VGS here, we have a VDS as well, and also a VTP. And so if we look over here and over here, we can write for this. So we know we have our VDS on one side, 1.71. And then we're going to have either a this, so less than, or a greater than or equal to. So we got to figure out which one it is. So on the right hand side, we're going to have our VGS, which is 0.63. And then we are going to have our VTP, so minus a negative 0.5. This is going to give us a 1.18. And this is going to be, if we look at from the left to the right, greater than or equal to this. And so that means it's in saturation. So if we go back to page 70 or 85, this was on page 78. But back at page 85, we have this equation, and we can just plug in our values. So using what we have here to the left, we are going to substitute these values in. And once we get this, I will bring down my Symbol Lab calculator that I use, plugging in these specific values. Again, this is not very important. What's important is knowing how to use the formula and why we're using it. And if we do this, we are going to get an answer in microamps, this is important right here, of approximately 42.9. And that's how we would go about solving this problem and thinking about it.